Hey everyone, and welcome. So, we've all been hearing about 5G for years now, right? And usually it's all about one thing it's just faster. But the real story here is so much cooler and more important than that. Today, we're going to dive in and find out why 5G is a total redesign of how our world connects. And it's a totally fair question. For most of us, our 4G LTE phones work just fine. We can stream our shows, browse social media, no big deal. So why on earth would we go through this massive global effort to build a whole new network? Well, the answer is all about what 4G couldn't do. And make no mistake, 4G LTE really was a masterpiece of engineering. When it was being designed, the creators had this laser focus on one primary goal: making smartphone apps work great. Every single piece of it was optimized to give you a fantastic mobile broadband experience, and it nailed that job perfectly. But the future started to demand a lot more than just a souped-up smartphone network. See, as these new ideas popped up, like the Internet of Things or cars talking to each other, 4G tried its best to keep up. But it just wasn't built for that stuff. Its rigid, one-size-fits-all design started to become a major bottleneck. This right here shows the huge shift in thinking. 4G was rigid, it was focused on that one smartphone job. But 5G was designed from the very beginning with a totally new mantra: flexibility above all else. It wasn't built for one job. It was designed to be a chameleon, able to handle tons of completely different jobs all at the same time. And this is where we get to the core idea, the real aha moment of this whole thing. You see, 5G isn't just one network. It's actually a single, super flexible system that's built to serve three very different and often conflicting worlds, all at once. And these are the three pillars of 5G. Try to think of them less like features and more like completely different kinds of communication, each with its own crazy specific demands. So let's break down what each one is really all about. Okay, first up is EMB. This is the 5G you hear about the most, the faster speeds one. The best way to think about it is like a massive data superhighway. Its one and only job is to be fast. We're talking about creating a huge, fat pipe for moving gigantic amounts of data for things like virtual reality or 8K streaming. For EMB, other things like battery life, not really the main concern. Then, on the complete opposite end of the spectrum, you've got massive IoT. This is not a superhighway at all. This is like a vast, sprawling network of tiny city streets, connecting billions of simple little devices. For these things, speed is totally irrelevant. What matters? The number one priority is sipping power, making it possible for a tiny sensor to run for 10 years on a single battery. And that brings us to the third world, URLC, or Mission Critical Control. This is like the dedicated emergency lane on the highway. It's not about speed, it's not about battery life, it is all about near instantaneous response time and rock-solid reliability. We're talking less than a millisecond of delay. This is for things like remote surgery or self-driving cars, where even a tiny bit of lag is simply not an option. So here it is. This is the heart of the problem. These three worlds have needs that are completely at odds with each other. A network built for max speed is going to kill battery life. A network built for super low latency isn't great for connecting billions of tiny devices. A rigid, one-size-fits-all network like 4G just couldn't do it. And this is the fundamental problem that 5G was born to solve. So the big question is, how does 5G actually pull off this magic trick? How can it be three different networks all rolled into one? Well, it all comes down to some really clever technological breakthroughs that give it this incredible built-in flexibility. Let's take a look at one of the biggest ones. This slide just nails the difference. With 4G, you basically had one size of lane on the data highway. Everything, whether it was a tiny text message or a huge video file, was forced into that same 15 kilohertz lane. 5G, on the other hand, introduced something called scalable numerology. Fancy name, but what it means is that 5G can literally change the width of its data lanes on the fly to perfectly match whatever it's trying to do. And the result of this is just huge. That little IoT sensor that only needs to send a tiny blip of data, it gets a super narrow, efficient lane to save power. But your phone, when it's trying to stream an 8K movie, it gets a massive, super wide lane to pump through all that data. It's efficiency, custom built for the task. Now, the other big piece of the puzzle is real estate. 4G operated in a really crowded neighborhood of the radio spectrum, down below 3 gigahertz. What 5G did was unlock this massive, new, untouched territory of super high-frequency airwaves called millimeter wave. It was kind of like discovering a whole new, completely empty freeway system right next to the old, congested one. Just massive amounts of new space for data. All right, so we get the why and we get the how. But how has this technology actually made it out into the real world? Well, it wasn't as simple as flipping a switch. It's been a journey, rolled out in stages. So the very first version of 5G that we all got was something called non-standalone, or NSA. And it was a really clever way to get things going fast. It basically used the existing 4G network as the brain to handle all the control stuff, but then it bolted on a new 5G radio to act as a big, fat data pipe for more speed. But the real destination, the end goal, is standalone, or SA. That's where the entire network, the brain, the radios, the whole shebang, is pure 5G. And that's what unlocks its true power. And we can see this exact journey playing out right here. It started back in 2018 when the first standard was all about getting those early non-standalone networks off the ground. By 2020, we started to see the first true standalone networks flicker to life. And now, today, that shift is really picking up steam as more and more networks go fully standalone, finally unlocking all those futuristic possibilities. So, let's wrap this all up. What are the big things you really need to remember from all this? What's the true story of the 5G revolution? Okay, if you remember anything, remember this. First, 5G's real genius isn't just speed, it's flexibility. It's the ability to adapt. Second, it was built from day one to serve 3 totally different worlds: the speed world, the massive device world, and the instant response world. And finally, it's new tech, like those adjustable data lanes and brand new airwaves that makes this whole new era possible. And that really leads us to the final and, honestly, the most exciting question of all. 5G isn't really the end goal. It's the foundation. It's the toolbox for a whole new generation of innovators and creators. So the real question isn't what 5G can do, it's what are we going to build with it?